For 55 hours, it had been a textbook mission. A smooth launch, a flawless coast toward the moon. Aboard the spacecraft Odyssey, the three astronauts, Commander Jim Lovell, Command Module Pilot Jack Swigert, and Lunar Module Pilot Fred Haise, were settling into the quiet rhythm of deep space. They had just completed a television broadcast, showing a smiling world, their life inside the ship. It was serene, almost mundane. Then, a dull, muffled thump shook the vessel. It wasn't a violent jolt, but it was wrong. Deeply, fundamentally wrong. In the silence of space, there are no unexplained noises. A moment of confusion was cut short by the blaring of a master alarm. A warning light for the main electrical bus flashed ominously. From the command module, Jack Swigert's voice, calm but urgent, radioed down to Earth. "Okay, Houston, we've had a problem here." Jim Lovell, looking over from the lunar module, where he was working, added the confirmation that would echo through history. "Houston, we've had a problem." He then glanced out the window, and his blood ran cold. "What the hell was that?" Fred Haise asked, the routine of moments before shattered. Lovell's eyes were fixed on the terrifying view outside. "We're venting something," he said, his voice tight. "We're venting something to space." It wasn't just smoke or debris. It was a glittering, sunlit cloud of gas. The spacecraft's own lifeblood. It was oxygen, the very air they breathed and the power source for their fuel cells, bleeding out into the infinite blackness. The electrical gauges began a sickening plummet. One of the two main oxygen tanks was reading 0. The second was slowly, inexorably emptying itself into the void. In an instant, the goal of landing on the moon vanished. The mission was no longer about exploration. It was now about survival. The question was the most terrifying a human could ask in the void of space.
Can we get back?
Before the explosion, Apollo 13 was a mission of precision and scientific ambition. It was the third intended lunar landing, and its target was one of the most geologically intriguing sites on the moon, the Fra Mauro Highlands. Scientists believed the debris there, thrown up by a massive ancient impact, could contain the very history of the lunar surface, offering clues to the moon's formation billions of years ago. The men chosen for this task were not just astronauts. They were a perfectly balanced team of veterans and specialists. At the helm was Commander Jim Lovell, a NASA legend on his fourth and final spaceflight. He was one of the most experienced astronauts in the world, a man who had already flown to the moon and back on Apollo 8. For him, this was the culmination of a career, a chance to finally walk on the surface he had only orbited. The lunar module pilot was Fred Haise, a dedicated and sharp-eyed engineer on his first spaceflight. While Lovell was the commander, Haise was the technical master of the lunar lander, Aquarius. He had trained for every conceivable detail of the descent to Fra Mauro. This was his dream. Originally, the command module pilot was to be Ken Mattingly, but just days before launch he was exposed to German measles. Despite being immune, NASA management, fearing he might fall ill during the flight, made a brutal last-minute decision. He was pulled from the crew. His replacement was Jack Swigert. He was a brilliant pilot, but he was stepping into a crew that had trained together for months. He had to cram years of procedures and team dynamics into a frantic 48 hours. Their mission patch featured 3 horses pulling the chariot of the sun across the sky, a symbol of Apollo pulling the light of knowledge to Earth. It was a noble, inspiring goal. But in the minutes after the explosion, that goal shattered. The intricate dance of checklists for a lunar landing was now a useless weight. In the frantic hours after the explosion, as the astronauts fought for their lives and mission control scrambled for answers, a single pressing question dominated. What just blew up? The answer would not be found in the void of space, but in the meticulous paper trail and memory of engineers on the ground. It was a flaw that had been built into the spacecraft long before it ever left Earth. The source of the cataclysm was Oxygen Tank 2, nestled deep within the service module. To understand its failure, we have to go back 2 years, to a factory floor. The tank was, in essence, a high-tech thermos designed to store liquid oxygen at nearly 300 degrees below zero. Inside it were a fan, a heater, and a delicate web of wires, all used to measure and stir the tank's super-cold contents. But this particular tank had a history. It was originally installed in the Apollo 10 spacecraft. During its removal, it was accidentally dropped a short distance, about 2 inches. The jar was slight, seemingly insignificant. A post-incident inspection revealed no major damage, but the event was a hidden crack in the foundation. The real tragedy, however, was in the modification. The spacecraft's power voltage was upgraded from 28 volts to 65 volts to support more complex systems. Incredibly, the thermostatic switches inside the oxygen tanks, the very safety mechanism designed to prevent overheating, were not upgraded to handle this new, higher voltage. It was like installing a powerful new electrical system in a house, but forgetting to replace the old, fragile fuses. The chain of failure was now set. During a routine pre-launch test, the ground crew found they couldn't drain the oxygen from Tank 2. Their solution? Turn on the internal heaters to boil the oxygen off. But because of the outdated, under-spec'd switches, the heaters didn't cycle on and off as they should have. They stayed on, superheating the tank to over 1,000 degrees Fahrenheit. This inferno, unbeknownst to anyone, scorched the Teflon insulation off the wires inside the tank, leaving the bare electrical wires exposed. For weeks, Oxygen Tank 2 flew with a time bomb inside it. When Jack Swigert, following the flight plan, flipped the switch to stir the tank's contents, those bare exposed wires sparked. In a tank now filled with gaseous oxygen, that spark found its fuel. The resulting explosion wasn't a bomb, but a violent, pressurized rupture. It blew the entire side panel off the service module and crippled its neighboring Oxygen Tank 1. The explosion was a lesson written in fire and ice. In spaceflight, there is no such thing as a minor flaw. Every component, every wire, and every forgotten detail carries the weight of human life. Back in mission control, the data was painting a picture of a dying spacecraft. The screens showed Odyssey's main power buses fading. The 2 main fuel cells, which needed oxygen to generate electricity and drinking water, were dead or dying. It was clear. The command module, the ship designed to bring them home, was becoming a lifeless, powerless shell. The clock was ticking. In a matter of hours, the last bits of power would drain, and the crew would be left in a dark, silent coffin. In this moment of impending doom, a radical, untested idea began to take shape in the minds of the flight controllers. It was a concept that had never been more than a theoretical exercise in a simulator. The lunar module, Aquarius, was still attached to the crippled command module. It was their lander, their ticket to the moon's surface. But now, it would have to become something else. Flight Director Gene Kranz, his voice cutting through the tension in the control room, made the call. Okay, all, let's work the problem. We're not going to panic. Let's figure out how we can use what we've got to get them home. The order was given to the crew. Power up the lunar module Aquarius. This was a monumental task. The lunar module was designed to support 2 men for 2 days on the lunar surface, not 3 men for 4 days in deep space. Its systems were separate, its engines designed for landing, not for a trans-Earth injection burn. Jim Lovell and Fred Haise began the frantic, multi-step process of bringing their lifeboat online, while Jack Swigert and the command module worked to preserve what little power they had left for the critical final moment of re-entry. The next decision was just as critical. What was their path home? The simplest option, a direct abort by turning around and firing their main engine, was immediately ruled out. No one knew if the explosion had damaged that engine, and using it risked another catastrophic failure. The only viable yet terrifying option was to continue their trajectory around the moon. They would use the moon's gravity as a slingshot to fling them back towards Earth. It was a longer path. It would take nearly 4 days, but it was the safest. It was a decision that required immense courage. To willingly fly further away from Earth, deeper into the void, trusting that their calculations and their fragile lifeboat would hold. The final, eerie step was the shutdown. To conserve every amp of power for the return, the crew was ordered to power down the command module Odyssey completely. One by one, the switches were flipped. For the first time, the 3 astronauts were fully enclosed in the cramped, cold, metallic confines of the Aquarius. They were now relying entirely on a spacecraft that was never meant for this. With the moon looming and then receding behind them, the crew of Apollo 13 settled into a grim new reality. The first and most immediate enemy was the cold. To conserve power for the critical life support and navigation systems, almost all non-essential equipment in Aquarius was shut down. This included the heaters. The spacecraft's interior temperature plummeted. Condensation coated every surface, the walls, the instruments, their flight suits. It was a damp, penetrating chill that seeped into their bones. Temperatures dropped to as low as 38 degrees Fahrenheit. The men, already stressed and exhausted, were now shivering constantly in the damp, metallic gloom. They could see their breath inside the cabin. The second enemy was thirst. The water supply was critically limited. The Aquarius's water was primarily for cooling its electronic systems, not for human consumption. The crew were placed on severe water rations, each man allowed only a few sips per day. Dehydration set in rapidly. Their lips cracked. The lack of water, combined with the constant cold, was a brutal physical tax. Fred Haise, already fighting the cold, began to develop a serious kidney infection, adding fever and pain to his ordeal. Sleep was nearly impossible. They took turns trying to rest in the slightly more spacious but freezing cold command module next door, which felt like a haunted, silent tomb. And then, a new, invisible killer emerged. A warning light illuminated on their control panel. The carbon dioxide levels were rising to a dangerous level. The crew was slowly suffocating on their own exhaled breath. The problem was one of simple, brutal geometry. The Aquarius was equipped with square lithium hydroxide canisters to scrub CO2 from the air. The command module had its own canisters, but they were round. They were incompatible. You couldn't fit a square peg in a round hole. The Aquarius's filters were becoming saturated, and once they were full, the toxic gas would claim the crew. In Houston, the call went out. A team of engineers was locked in a room with a pile of spare parts, only the items known to be on the spacecraft: plastic bags, cardboard from a flight manual, duct tape, a sock, a hose. Their mission? Build an adapter. On the ground, they frantically prototyped a Rube Goldberg-like contraption, testing it in a simulated cabin. The instructions were then read up to the exhausted crew who, with fumbling, cold-stiffened fingers, assembled the device that was quickly dubbed the mailbox. It was a bizarre, desperate piece of engineering. A plastic bag taped to a cardboard frame, connected to a hose, with a command module canister inside. They held their breath as they turned on the fan. It worked. The CO2 levels began to fall. They had, once again, cheated death with nothing but ingenuity and duct tape. But the victory was temporary. They were still cold, dehydrated, and exhausted, drifting in a silent, unforgiving ocean. Every system was being pushed far beyond its limits. The moon was now far behind them. For 4 days, the crew of Apollo 13 had been fixated on a single glowing point of light in their window: Earth. It was growing larger, a beautiful and terrifying sight. It was the finish line, but to cross it, they had to survive the most perilous part of their journey yet: re-entry. The final 24 hours were a marathon of meticulous, sleep-deprived preparation. Every action was calculated, every ounce of power conserved. But first, they had to confront the full extent of the damage. The time came to jettison the service module, the section of the ship that had housed the exploding oxygen tank. As the latches released and Odyssey slowly rotated, Jim Lovell peered out the window. What he saw sent a chill through him that was deeper than any caused by the cold. "There's one whole side of that spacecraft missing," he reported, his voice a mixture of awe and horror. The entire bay panel was blown away, exposing a tangled mess of torn wires and crumpled metal. The explosion had been far more violent than anyone had imagined. The sight was a gut-wrenching confirmation of just how close they had come to instant annihilation. Now, only 2 modules remained: the cramped, faithful lifeboat Aquarius and the cold, dormant command module Odyssey. The next step was the most emotionally difficult: saying goodbye to the ship that had saved them. The lunar module Aquarius was never designed to withstand the heat and forces of Earth's atmosphere. It had to be jettisoned before re-entry. With a final, grateful farewell, Lovell spoke the words that echoed the feelings of the entire world. "Farewell, Aquarius, and we thank you." They hit the separation switches. The lifeboat, their home and protector through the long, dark journey, drifted away into the void, a silent hero destined to burn up in the atmosphere. Now, they were alone in the dead, ice-covered shell of the Odyssey. For the first time in days, Jack Swigert, the command module pilot, was back in his rightful seat. The most critical and uncertain power-up in history began. One by one, they flipped the switches, praying that the ship's essential systems, frozen and dormant for days, would awaken. The world held its breath. A collective sigh of relief was felt in mission control as navigation systems, guidance computers, and finally, the crucial re-entry batteries came online. The ship was alive, but barely. Then came the blackout. As Odyssey slammed into the upper layers of the atmosphere, a superheated plasma of ionized air enveloped the capsule, severing all radio communication. For 3 minutes, this was normal, but the calculated blackout period was coming to an end. In mission control, all eyes were fixed on the clock. 3 minutes passed, then 4. The room was silent, the tension unbearable. Kranz and his team could only wait and hope that their calculations were right, that the heat shield, potentially damaged by the explosion, had held. 4.5 minutes, still silence. Had they survived the cold of space and the ingenuity of 100 fixes, only to burn up in the final seconds? Flight Director Gene Kranz, his face a mask of controlled anxiety, silently willed a signal to appear. Then, a voice crackled through the static, calm and clear. It was Command Module Pilot Jack Swigert. "Okay, Joe." It was the prearranged signal to the Capcom that the drogue parachutes had deployed. Cheers erupted in mission control, but were quickly hushed. They needed the final confirmation. Minutes later, the sight of 3 magnificent red and white main parachutes blossoming above the blue Pacific Ocean sent an uncontrollable wave of relief and jubilation through the room. The spacecraft Odyssey splashed down gently into the waves. They were home. On the USS Iwo Jima, recovery crews swiftly retrieved the exhausted but alive astronauts. They were dehydrated, freezing, and Fred Haise was seriously ill. But they had survived an ordeal that should have been fatal. The world, which had been holding its breath for days, exhaled in a collective, joyous celebration. In the aftermath, the Apollo 13 mission was dubbed a successful failure. It had failed in its original objective to land on the moon, but its success was far greater. It became one of history's most powerful testaments to human ingenuity, composure, and teamwork under pressure. The investigation that followed confirmed the chain of failure that began with the damaged oxygen tank. More importantly, it led to significant redesigns. The oxygen tanks were completely overhauled with redundant systems and safer heating elements, and a third oxygen tank was added to the service module. But the true legacy of Apollo 13 is not just in hardware. It is a permanent lesson in crisis management. The can-do spirit of the engineers on the ground, who invented solutions with cardboard and tape, became the stuff of legend. They proved that even when technology fails, the human spirit, when combined with intelligence and determination, can perform miracles. The splashdown in the Pacific was not an end, but a beginning. The mission left behind a legacy that forever changed human spaceflight. First, it was a masterclass in crisis management. The phrase "failure is not an option," famously attributed to flight director Gene Kranz, even if he didn't say it verbatim during the crisis, became the mantra of the mission. It encapsulated the mindset of absolute commitment to finding a solution, no matter how dire the circumstances. The Apollo 13 mission control team became the gold standard for teamwork under extreme pressure, a case study now used in business schools and leadership seminars worldwide. Second, it forced humility and rigor back into NASA. The agency had become confident, almost cavalier after the stunning successes of Apollo 11 and 12. The can-do spirit was starting to overshadow the "should we" caution. The oxygen tank explosion was a brutal, necessary reminder of the unforgiving physics of space. In its wake, NASA instituted sweeping changes. A complete redesign of the service module's oxygen tanks, the addition of a third backup tank, and the creation of new review processes to question every assumption and scrutinize every component with renewed vigor. But beyond the technical fixes and the management lessons, Apollo 13 gave us something even more profound: a new narrative for exploration. For a brief, terrifying moment, the whole planet became invested in the safe return of 3 men. We were watching fellow humans, cold, thirsty, and exhausted, using their wits to overcome impossible odds. The hero of the story was not just the astronaut. It was the engineer on the ground with a roll of duct tape. It was the flight controller who refused to panic. It was the universal human capacity for ingenuity. If this journey into the heart of a successful failure moved you, if you believe that these stories of crisis and comebacks are vital to remember, then you're already part of our community. Subscribe to the channel and ring the notification bell. By doing so, you're not just watching a video, you're casting a vote for the kind of stories that matter. Stories that remind us of our fragility and our brilliance. Leave a comment below. Tell me the story you want to uncover next, the failure you want to understand, or the triumph that inspires you. Let's continue this journey together, exploring the final frontier, one story at a time. Thank you for watching.